Okay, this video begins our first day of distance learning. So you might notice that we skipped the 5.2 activities. We did the constraint activity a while ago, but the 5.2 activity we really can't do because that's an Autodesk Inventor activity. So we're going to do a modified 5.3 activity instead. And that's where we start today. So firstly, we have some definitions. So mass is a measure of the amount of matter that an object has or the quantity of inertia in the object. Okay, and the way you get mass is you can use a triple beam balance to measure mass. We are most familiar with weight. And weight is actually a force caused by the acceleration of gravity acting on the mass of an object. So scales like those found in the grocery store or a doctor's office are used to measure weight. So you want to definitely know the difference between weight and mass. Okay, mass is the inertia quality. It never changes. Weight does change depending upon the force of gravity. So in this box down here, what we have is weight, mass, and the force of gravity. And you can see we have it measured in U.S. customary units, so pounds. Mass in U.S. customary are either slugs, which we'll discuss in a little bit, or pound mass, which is denoted lbm. Acceleration of gravity in U.S. customary units is 32.2 feet per second squared. And notice it is 9.8 meters per second squared in the metric system. Okay, the usual units for mass in the metric system are kilograms, and the usual units for weight in the metric system are newtons. So you become familiar with these terminologies. Okay, let's go on to the next page. Okay, on this page, I ask you to do some calculating of weight when given mass in kilograms. So what is the weight, so they're looking for weight, of an object that has a mass of 100 kilograms. So weight equals mass times the force of gravity. Okay, this is a formula that you should become very familiar with. So here's your mass, the 100 grams. Because we're in the metric system, we're going to use 9.8 meters per second squared. And notice that the result is weight in newtons. Okay, so then there's a second example here. This time I halved the weight. So let's see what I'm getting here. So 50, I believe I have that wrong answer down there, so let me just check that. 50 times 9.8 is going to be, half of that. So this should be 490. So I'll change this on your sheet before you even see it, but 490 is the answer you should be seeing. Okay, let's go on to the next page. Okay, notice in this on this page, the question that we're going to go over is, what is the mass of an object that weighs 42 pounds? So the weight is given, the mass is desired. So an object that weighs 42 pounds on Earth has a mass of 1.3 slug. Okay, that's that word I told you we're going to get to, or 42 pounds mass. Okay, so pounds m is what we want. That tells me that's a mass. So look at the calculations below. So here are the calculations, but I'm going to walk you through this. So when you convert mass in slugs to mass in pounds mass, the conversion factor is 1 slug equals 32.2 pounds mass. Okay, now this is the conversion factor on Earth. All right, so, well, actually, it's always a conversion factor, but on Earth, it has a special characteristic, which we'll go over in just a sec. Okay, so in non-technical terms, having this conversion factor neutralizes division by G, which is the force of gravity. So look at what they're doing. Here's your equation, weight equals mass times gravity. The next step is they rewrite it so that you are trying to find mass. So you take the weight, which is in pounds, so 42 pounds. The force of gravity is 32.2 feet per second squared in the U.S. customary system. This gives us a mass of 1.3 slug, okay? But you don't usually walk around talking about how much something weighs in slugs. So we then use this conversion factor right here to get it back to 42 pounds in mass. Okay, so it's pound mass. That's what you call this last term. Okay, so what are you noticing? You started out with 42 pounds, and you ended up with 42 pounds mass. Does that make a difference? And the answer is yes, because you had to take into account gravity, and then you had to reconvert. So this is how we're going to do this. Now, the next page, we show you what happens if you're talking about earthly gravity. The moon's gravity instead. Then you get a different number. Okay, so let's do that next. Okay, so this is an important point to note right up here, that the mass of an object will not change. However, the weight of an object can vary if it experiences a different gravitational acceleration, such as the acceleration of gravity on the moon or Mars. So here's an example with on the moon. Look how it impacts the results. So first off, you are provided with mass, and so you have 42 pounds mass, okay? And now gravity in this situation is 5.32 feet mass per second squared. So if you're going to convert lbm, which is pound mass, to slugs, okay, we have 1.3 slugs, and then we say weight equals mass times gravity. Here are your 1.3 slugs. Now look what your gravity is. Your gravity is not this term above. Gravity on the moon is less. So look what happens. Your weight is less. So if we were doing this whole experiment on Earth, your answer would have been the weight is 42 pounds. But because we had a different gravity, it's not 42 pounds. So you have to see what the gravity force is and work with that appropriately. Okay, let's go on to the next page. Okay, our next topic is volume. So we did mass and weight, and now we're going to do volume. So you're going to have to use your engineering formula sheet, and if you wanted to print out a new one for yourself, it's under Student Resources on Project Lead the Way. But I have cut and pasted some of the formulas here. So these are the formulas we're going to be working with. A sphere. Notice the sphere, the volume is calculated by saying 4/3 pi r cubed. So I'm going to have you put pi into your graphing calculator. I'm not going to have you approximate. I'm just going to have you put the key in. Frequently, they'll have you tell you to approximate it to 3.14. We're not going to do that here. All right, another key thing. Many times the problem will give you a diameter and not a radius, so you have to know that the radius is the diameter divided by 2, and just be careful about that. Okay, let's go on to the next page. Okay, here are two more formulas that are going to be needed. One is for cube, so volume is always going to be in cubic units, whatever the units might be. Your end result is going to be something cubed. Okay, so that's one thing to know. The side length is going to be consistent all the way around since it's a cube. All the measurements are exactly the same. Look at the cylinder. The cylinder's volume is going to be pi r squared times height. So again, if you're given diameter instead, you've got to make sure you make that conversion so that your numbers are correct. Okay, let's go on to the next page. Okay, on this page I cut and snipped Some of the other equations that we'll need, notice that is from your engineering formula sheet. And so those are things that we'll use throughout this lesson. This is that example with weight and mass conversions. So I just put that here again just for your convenience. Okay, had we been doing this in class, we would have been measuring volume of irregularly shaped items using water displacement. So you put the 4 items in and you see how much the water goes up once they're in there, and that is an approximation of the volume. Okay, those your units that you've been measuring would be in millimeters cubed, but 1 millimeter cubed equals 1 centimeter cubed. So your end result would be you'd be able to have an approximation for volume in centimeters cubed. Okay, there's a way to read this, and we'll do that on the next slide. Okay, when you read a water level, you're going to record the lowest point on what's called the meniscus shape. Okay, so read that lowest point. The volume of the object is equal to the volume change recorded after adding the object to the water. Read the lowest point. Okay, we've exaggerated this shape so that you can see what I mean. So you're going to be reading right here. Okay, let's go on. Okay, so density and volume go hand in hand because density is the measure of the amount of matter per unit volume. Okay, so you can see if you look at these molecules in these boxes, this clearly is high density in figure 3 and low density in figure 4. So there are 2 types of density, mass density and weight density. Okay, mass density is mass per unit volume, defined by the equation on the left below, or more accurately in our sheet on the previous page. Weight density is the equation is measured by weight per unit volume. Weight density is commonly represented in U.S. customary units. Okay, so that is the end of this video. You're going to use this information to do some practice problems. I'm sorry, I spoke a little bit too quickly. I wanted to present these formulas to you so you have them all in one place. Okay, you have it on the table, but they also refer to it here. So this is that formula, and weight density is this formula. So notice, take careful note of what your units are. If you're in mass density, you can report in grams per centimeters cubed or kilograms per meters cubed. Weight density, you'd be reporting in pounds per inches cubed or pounds per feet cubed. All right, so the important thing is knowing that you have cubic measurements for volume in both cases. All right, we're going to use these equations to work on our homework sheet.